Honorable attendees and distinguished guests, please give a warm welcome to NAE Chair Don Winter.
Good afternoon. Got that right. This is our third shot. It is my great honor and privilege as the NAE Chair to welcome all of you to the 2022 National Academy of Engineering annual meeting and the induction of the class of 2022. I am most pleased that we are finally able to have an in-person induction ceremony. I remember my own induction fondly, and I trust that you will find today's ceremony as meaningful as I did. For many of the new members, this is your first introduction to the Academy. Election to the NAE is a high honor, and I trust that you will take great satisfaction in being so recognized by your peers. I expect that your families also take great pride in this accomplishment. But while the NAE selects its new members based on an exhaustive search and evaluation process, it is much more than just an honorific society. The National Academy of Sciences was established in 1863 by Act of Congress. Its charter directs the Academy to, and I quote, "Whenever called upon by any department or agency of the government to investigate, examine, experiment, and report upon any subject of science or art." The National Academy of Engineering was founded in 1964 under that charter. I will let John Anderson describe the operating structure of the National Academies of Sciences, Engineering, and Medicine, but I will note that our role as an advisor to the nation on technical matters has been a core responsibility for over 150 years. During this period, the academies have been relied upon to provide independent, objective, and nonpartisan advice with the highest standards of scientific and technical quality and integrity. To do so, the academies call on the nation's preeminent experts in science, engineering, and medicine. In this process, the often critically needed engineering perspective has been and will continue to be a major demand function for the NAE. I expect that the need for such engineering inputs will increase significantly in the next several years. The past 2 years have been difficult ones as we learn to deal with the COVID pandemic. Not surprisingly, but not all that well known, is the significant roles that engineers and engineering processes played in developing, producing, and distributing the vaccines that have contributed immeasurably to the control of the virus and its impact. Now, while we are learning to live with COVID, we need to recognize that its long-term impact goes well beyond the world of healthcare. COVID has changed society in many ways, from where people choose to live to the nature of work itself. It is my belief that we are just starting to understand the impact that such changes will have on our national infrastructure, impacts that will need to be addressed by public policies informed by engineers. Add to that the public policy issues surrounding climate change, and it is evident that our nation will need the NAE's advice and counsel in the years to come. The need for such knowledgeable advice becomes evident when one looks at just a small part of the problem, such as the transition from a hydrocarbon-based economy to one based on renewable sources of energy. Providing uninterrupted electric power 24 hours a day, 365 days a year is massively challenging. The difficulties are evident in Europe, where the transition to solar and wind power has been complicated by varying weather conditions, early deactivation of nuclear power sources, and limits on natural gas availability from Russia. The policies behind the transition from hydrocarbon-based energy sources to renewable sources needs to be informed by engineering principles and judgments. As a systems engineer, I am dismayed by the limited perspective that appears to underlie many of these policies. Change in the form of reduced CO2 emissions is typically the desired outcome. But change at what cost? And cost is not restricted to financial measures, but can run the gamut from increased susceptibility to weather events to supply chain constraints for rare earth materials. Only by identifying and addressing the full range of collateral impacts can the full cost and the likely timing be understood. The transition of electric power must be engineered to be successful. It must consider the potential for reduced CO2 emissions, the cost and timing of such reductions, and all of the collateral implications. It will also need to consider a full range of alternative mechanisms for producing and distributing electric power, including nuclear technology. I am pleased to say that your NAE is embarking on the challenge. As but one example, I will note the study initiated and co-organized by the NAE that is examining the potential for commercialization of new and advanced nuclear reactor technologies. This is a broad-based examination of the problem, examining safety, nuclear waste, and workforce issues, as well as multiple technology options and implementation paths. Although it is but one facet of the challenge to transition away from a hydrocarbon-based electric power grid, it has the potential to materially impact national policy debates on the future direction of electric power generation. Now, I'd be remiss if I did not note that this study was enabled by a most generous gift from NAE member James Truchard. This independent funding greatly aids our ability to independently and flexibly explore multiple alternative paths of development. All too often, studies requested by the federal government come far later in the policy development cycle and can be focused on specific alternatives. We need more contributions to help the Academy provide the engineering leadership and advice that's sorely needed. And we need more members to participate in the related National Research Council committees, boards, and NEE programs. For those of you who have served, I would like to thank you and ask that you continue to do so, perhaps at even greater levels of involvement. For those of you who have not yet done so, I will encourage you to participate. I believe that you will find this form of service to be both intellectually challenging and most satisfying. Now, it is my pleasure to introduce John Anderson, the distinguished president of the NAE, to deliver his address. John?
Thank you, Don, and welcome everyone to the 2022 National Academy of Engineering Annual Meeting and Induction Ceremony. It is refreshing to see so many of you in person. I would like to also welcome family and friends joining us today. Before we start, I would like to express our sympathy and support for the residents who are in the path of Hurricane Ian, especially in Puerto Rico and Florida. The storm reminds us that there remains many challenges for engineering to secure the health and safety of our population. We will use our ingenuity to rebuild areas to be more robust and resilient, to secure the health and safety of our society. This is the moment we have been anticipating, your moment, to be formally inducted into the National Academy of Engineering. Inducting 3 classes in one day is a tall order. You are number 3. We have practiced on 2 other classes. So I think we're doing pretty well right now, right? It's a first step in moving on from the pandemic, and it's an exciting step. It has been 3 years since we held an induction ceremony in person. I would like to recognize the hard work, patience, and resilience of NAE members, staff, volunteers, and partners. We managed by working and collaborating electronically, seeing faces through computer monitors. The technologies at our fingertips made our work possible. But it's the people, our current NAE members, who ensured the important work of the NAE continued. And thank you for that. And it continued uninterrupted. NAE is one of the 3 pillars of the National Academies. The National Academies of Sciences, Engineering, and Medicine serve the nation by providing independent, objective advice to inform policy, sparking progress and innovation to solve complex problems, and confronting challenging issues to benefit societies. The academies encourage education and research, recognize outstanding contributions that benefit society, and increase public understanding of science, engineering, and medicine. Interestingly, the need to cultivate science and advanced technology was amplified in response to the wartime needs of our country. It is against the backdrop of the Civil War that the National Academy of Sciences was first chartered in 1863 by President Abraham Lincoln. You can see a portrait of this in the boardroom on the other side of the building. At its inception, the NAS, National Academy of Sciences, was composed of scientists, engineers, and technologists, and medical professionals. In the shadow of World War I, in 1916, President Woodrow Wilson approved the formation of the National Research Council to advance science, aid American industries, and promote national security and welfare. Membership was drawn from the government, various branches of the military, universities, and private research laboratories and businesses. As technology advanced, the practices of engineering became more prevalent, and the need for engineering to have an explicit role in advising became more pronounced. In 1964, the NAE was established under the original NAS, National Academy of Sciences Charter. It was touted as a major landmark in the history of relationships between science and engineering in our country. The 3rd pillar of the academies was formalized in 1970 by the addition of the National Academy of Medicine, which was originally named the Institute of Medicine. The National Academies of Sciences, Engineering, and Medicine, which we call NASEM now, is a trusted voice for evidence-based studies, reports, and discussions that address the science, engineering, technology, medicine, and policy issues of the day. The depth of knowledge and diverse perspectives that you, our members, bring to the table makes reports and studies from the National Academies the gold standard of technical advice. There is unity in our autonomy, and there is autonomy in our unity of the 3 academies. But we all serve one mission: to provide unbiased, evidence-based recommendations in service to our nation. Many of you took part in the Big Picture Expo yesterday, and I thank you for being there, and you became familiar with the NAE programs and NASEM divisions. It was a great turnout. I hope you learned how to engage in the work of the academies in ways that are meaningful to you. Service is an important aspect of NAE membership, as Don Winter emphasized. In 2021, 46% of our members participated in activities of the National Academies generally, and the NAE specifically, by serving on committees, lending their expertise to reports, and by taking on an active role in our member elections. Your expertise and participation is needed as we continue to fulfill our mission. So the message here is your induction into the NAE is like a university commencement. It's the beginning. And it is the beginning of an important service to the nation and to the engineering profession. It is obvious that our climate is changing and in dramatic ways. We must be responsive to those changes through programs and activities, and we must respond strategically with the urgency required. Accelerating decarbonization of the U.S. energy system is one of the National Academy's most cited reports. Released in 2021, it has been downloaded more than 18,000 times. Its committee members have testified to Congress, in front of Congress, and it has influenced policy on addressing climate change. Because of the urgency of this topic, the focus of our Monday sessions at this meeting is engineers leading the energy transition. We can look forward to insightful talks both about the challenges and the opportunities that await the engineering community. Pictured here are some of the founding members who attended the first annual meeting of the NAE in 1965, a year after the NAE was established. These are 15 of the 25 members. The 25 were originally inducted in. 52% are from the business sector, 36 were from the universities, and 12% from national laboratories. These men were giants in their field. Among them were James Landis, a power engineer who was in charge of what was at the time the world's largest generating plant, and William Everett, an electrical engineer who pioneered advances in radio engineering and communication. I'd also like to point out that a hallmark of NAE is significant representation of members from industry who bring expertise and perspectives about combining scale and cost not found in the academy or government. Of our three academies, the NAE is the only one with significant membership from business. I want to also point out that something about this picture that stuns me a bit. Okay, they're all men. They're all white. But what really gets me is they all dress the same way. So we've come a long way, not on the first two, but also in our dress. Let's forward to the present. Here are photos of some of the members of the class of 2022. Quite a difference from the composition of individuals you saw on the previous slide, the class of 64. Our membership representation reflects our values. We aim to increase representation from industry and among women and underrepresented minorities. A more diverse and inclusive academy means that more constructive and creative ideas are brought to bear in our work. We are committed to convening knowledge to provide engineering leadership on issues that all countries face. These issues include clean energy, access to potable water, food security, and protecting health and well-being during times of national crises, such as pandemics and natural disasters, like the one we've just faced. The need for collaboration with members across the world is a new urgency. This year, we increased the number of members from underrepresented countries such as Singapore, South Korea, Taiwan, and Turkey. Welcome to the 24 international members elected from 17 countries. And we look forward to working with you on global issues that impact all of us. Today, with 2,300 U.S. members and 300 international members, the NAE embraces another chapter of reaching new frontiers of creativity and innovation to address pressing challenges. NAE elects more than half of our members from the business sector. We are the source of expertise from industry and the national academies. I also want to call to your attention the fact that a significant part of this class, according to this slide, is of naturalized citizens. Immigration is obviously a very important asset of this country. Finally, we have broadened the representation of members with respect to women and individuals from underrepresented groups. In 2021, we revisited our strengths and with input from members and staff devised a new strategy to provide insights and leadership with a focus on people, systems, and culture. Our commitment to the nation, our profession, and our members is prioritized in the 4 I's. Identify and inform the frontiers of engineering theory, practice, and policy. Increase engineering talent through a strong commitment to diversity and inclusion. instill a culture of ethical and environmentally responsibility in engineering, and improve capabilities and competencies for complex systems engineering. In May, the NAE Council approved the strategy's implementation plan that will help maintain our progress in reaching the goals shown on this slide. It is important to point out that the national academies are not part of the government, and this is by design. This ensures that the essential work we do remains objective and credible. One result of our independence is our dependence on philanthropy. About 60% of the NAE's operating budget, the portion in green you see on this slide, derives from past and current donations from our members, foundations, corporations, and other partners. Your leadership, now more than ever, is critical to the success of efforts to advance the NAE to an even higher level. Engineers are at the heart of solving global-scale challenges that affect all people. These challenges create opportunities to learn, improve, and expand the engineering field, provided we are prepared to answer the call. We can, we will, we are engineers. Wow. After that, who wouldn't want to be an engineer? I can't imagine anybody not. One of the best parts of that was when the young lady at the beginning points at herself. I really thought that was terrific. And I saw some of you tapping your feet and your hands, and I want to thank you for not getting in the aisles and dancing. It's actually got a pretty good beat. So, the Campaign for Leadership in a World of Accelerating Change seeks to support effective, action-oriented activities that enable and empower the NAE to be the trusted source of engineering advice for creating a healthier, more secure, and more sustainable world. Recently, I saw an engineer wearing a T-shirt with the statement, "I am an engineer." That means I get excited about things you don't even know about. Keep in mind that the word engineer derives from the Latin word for ingenuity. It does not come from engine, it comes from the word ingenuity. And a spirit of leadership to create what does not yet exist, according to our famous engineer, Theodore von Karman. It instills a need to tackle challenges, to find solutions, to create new things. This is what makes our practice and profession unique. I hope the video inspires you as much as it does me. I would like to thank the entire NAE staff who make our organization work so well. It's a wonderful group of individuals, great to work with, and they make good things happen like this meeting. This was not a simple meeting with 3 classes and a lot of things jammed in, and they did a fantastic job. We all owe them a great round of applause. Also, I thank the remarkable officers and counselors who govern the NAE. The Council is the governing body of the National Academy of Engineering. These officers and counselors serve the organization with integrity and dedication. Recognizing the work of so many reminds me of the quote by Helen Keller, "Alone we can do so little, together we can do so much." I look forward to doing wonderful work with each of you, and again, congratulations. Now, the moment you have been waiting for, the induction of the NAE class of 2022. And to lead us, I am pleased to introduce Dr. Al Romig, NAE Executive Director and NAE member, and a proud member of Section 1 Aerospace. He's also known as the Chief Skunk because of his leading role with Lockheed Martin's advanced development programs at the Skunk Works in California. Al, please introduce the members of the class.
Thank you, John, and good afternoon. So all three of us have remembered that we know how to tell time. Let's start. As John said, my name is Al Romig, and I am the current NAE Executive Officer. I began this role in 2015 after a career in aerospace, culminating at the Lockheed Martin Skunk Works. We are extremely proud of our new members. We're also proud of our long-serving members. At the back of the induction book, you will find the names of individuals who are celebrating a significant membership anniversary. Allow me to present this list class by class. At the end, I will ask all members celebrating the anniversary to stand so that we can properly acknowledge you. If you're watching on a webinar, feel free to stand at home. That's fine. I'd like to have the audience hold their applause until the members of all classes are standing, and then we congratulate them all at once. Feel free to applaud at home as well. The following individuals are celebrating a significant membership anniversary. The class of 1972, celebrating 50 years, Maury Tannenbaum. The class of 1977, celebrating 45 years. The class of 1982, celebrating 40 years. The class of 1987, celebrating 35 years. The class of 1992, celebrating 30 years. The class of 1997, celebrating 25 years. If all those individuals could stand, we'd like, John, I think you're in that list. John's one of the young ones. It was only 35 years. You also find that their names are available in the online directory. And as both Don and Don said, this is really a terrific occasion. After almost 3 years of not being together, we are finally together in this great auditorium in our nation's capital, and we are here in 3 dimensions. We are here to honor and acknowledge excellence in engineering as we celebrate the marvelous contributions that engineers in this year's class have made in research, innovation, manufacturing, education, the creation of novel technologies, and in designing solutions to real-world problems. I think you know how competitive this process really is. Several years ago, before both John and I were here, we had the pleasure of serving as the chairs of the Committee on Membership, 2014 and 16, if my memory is correct. And in those roles, we saw how talented classes are. In our present roles, we still have the opportunity to review this year's class, and I will tell you, you are all as distinguished as ever. Arthur C. Clarke, a former member of the NAE, now deceased, and author of 2001, A Space Odyssey, said that any sufficiently advanced technology is indistinguishable from magic. We take this moment to acknowledge some of the magic of engineering. Engineering is a marvelously creative enterprise, and the citations reflect that creativity. Engineering improves the human condition, and that is a message we are constantly trying to convey to the public, young and old. Engineering solves problems for people in society. John cited our history going back to the National Academy of Sciences in 1863 as an organization that is meant to use the talents of the nation's preeminent scientists, engineers, and physicians. And in light of the global challenges we face today, from pandemics to energy transition to climate change, now more than ever, it is important that the National Academy of Engineering continues to engage in this behavior. It may be an honor to be elected to the Academy, but you are here to serve the nation. Now it's time for the induction of our new members and international members. For all of those of you who are joining today, we make great efforts to introduce people properly by pronouncing their names correctly. I will tell you that with the help of my assistant, Jatrice, she did all the work. Between listening to voicemails, talking to you, talking to your assistants or your colleagues, and on occasion consulting Mr. Google, I will try my very best. Despite my American accent, do not hold that against me. Only one of you was at high risk of being introduced by your telephone number. Your titles and affiliations will appear on the screen, and I will read your name in the citation, and when I do that, that's when it's time for you to move up onto the stage, rather. Boy, this is the third time I'm doing this, so. Okay, so if we have John and Don take their positions and have Carol and Cameron come up on the stage and assume their positions. $200 down, $100 to go. One thing I will say is on occasion, because of weather and COVID, there will be people who won't be here that we were unaware that they would not be able to be here, and so we may in a couple of cases have instances of trying to introduce somebody who's here virtually. So we'll try to correct that. All right, here we go. Ahmadin K. Abdul Rabzak. For innovation in design, construction, and health monitoring of the world's tallest and most complex building structures. Nubar B. Afayan, for leadership in biotechnology, in particular mRNA therapeutics and chromatography. Michael V. Arbage, for leadership in developing and commercializing engineered enzyme products with industrial, consumer, and sustainability benefits. Brian Argro, for contributions to unmanned aerial systems capable of penetrating severe storms and leadership in their application to scientific observation. Mimi Ong, for development of the NASA Mars helicopter and the first flight on another planet. Anna C. Boulage, for creative and imaginative work in predicting the behavior of soft materials that are composed of multiple cooperatively interacting components. Richard Baranuk, for the development and broad dissemination of open educational resources and for foundational contributions to compressive sensing. Kathleen Bergeron, for contributions to and leadership in the invention and engineering product realizations of innovative designs. Rena Bezios, for contributions to the theory and applications of cellular tissue engineering, cell biomaterial interactions, and surface modification biomaterials. Alan C. Bovick, for contributions to the development of tools for image and video quality assessment. Charles R. Bridges, Jr., for leading the industrial development of new engineered device treatments in their cardiopulmonary space and for pharmaceutical innovation. Jian Chao, for pioneering a flexible sheet forming system and for leadership in manufacturing. Paul J. Carter, for creating novel approaches to discovery and developing life-saving antibody therapeutics, including bispecific antibodies. Robert L. Clark, Jr., for development of automated tools for rapidly identifying and indexing desirable genetic traits and for next-generation seed and biotechnology product development. Norma B. Clayton, for leadership in transforming manufacturing processes and supply chain management, and for innovative training programs for commercial aerospace industries. John M. Cohn, for improving design productivity of high-performance analog and mixed signal circuits and for evangelizing STEM education. Mary Chedvinsky, for the application of psychological principles to the design and understanding of human-computer interaction. John Davies, for contributions in computer technology to improve education and healthcare, stimulate economies, and enrich lives throughout underdeveloped countries. James J. DiOrio, for advances in material synthesis from nucleation to large-scale crystal growth. Michael Dettinger, for hydroclimate research that significantly enhanced the understanding and management of water resources in the western United States. Nancy J. Dudney, for contributions to the development of high-performance solid-state rechargeable batteries. Louis Dorlofsky, for the development of innovative modeling and optimization techniques to enable the recovery of hydrocarbon and water resources. Taher El-Gamal, for contributions to cryptography, e-commerce, and protocols for secure internet transactions. Stephen D. Fantone, for contributions to optical engineering and the development of optically based products and metrology systems. Nuria I. Fernandez, for forging innovative strategic partnerships and public policies and guiding complex transportation planning and operations. Barbara A. Filas, for business leadership, mining engineering achievements, and being a role model, especially for young women mining engineers. Denise Gray, for leadership in the development and production of electronic controls and battery systems for electrified passenger car propulsion system applications. Farshid Gilak, for contributions to regenerative medicine and mechanobiology and their application to the development of clinical therapies. Jerome F. Huzar, for development of design criteria and models for stability and seismic design of innovative steel and composite structures. William S. Hammock, for innovations in multidisciplinary engineering education, outreach, and service to the profession through development and communication of internet-delivered content. Daniel M. Hart, for engineering leadership in the development and operations of satellites, launch vehicles, missile defense, and national systems. Yusef M. Hashash, for contributions to geotechnical engineering, seismic safety, and the evaluation, design, and construction of underground infrastructure. John D. Hooper, for advancement of building code seismic design provisions and earthquake-resistant structural design of major buildings around the world. Bauman Havida, for entrepreneurial leadership in the development of advanced energy management system software for electric utility operations. Freeman A. Hrabowski III, for development of a national educational model for students from diverse backgrounds to excel in engineering and science. Nola M. Hilton, for engineering development and leadership in breast cancer MRI and multi-center national trials improving the health of millions of women. Petrus Ioannou, for contributions to robust adaptive control and intelligent transportation systems for improved traffic flow and driver safety. Bahram Jalali, for contributions to silicon photonics, high time resolution scientific instruments, and biomedical imaging. Samson A. Janicki, for discovery and understanding of conjugated materials for organic light-emitting diodes widely used in the commercial sector. Christopher W. Jones, for contributions to the design and synthesis of catalytic materials and for advancing technologies related to carbon capture and sequestration. George E. Karniadakis, for computational tools from high-accuracy algorithms to machine learning and applications to complex flows, stochastic processes, and microfluidics. Thomas W. Kenny, for the performance enhancement and commercialization of silicon MEMS resonators for timing applications. Mladen Kazunovic for contributions to automated analysis of power system faults and leadership and education in protective relay. Teresa Contact for contributions to the development of commercial material products and for facilitating advanced manufacturing technology. Nicholas D. Lapos for improving rotary wing flight performance and serving as test pilot, engineer, inventor, technologist, and business leader. Mark S. Lavoie for contributions to computer graphics and digital photography. Rebecca Lieberd for leadership in developing and executing innovative initiatives to strengthen the U.S. manufacturing industry. Chao-Sin Lin for the development of aerospace environmental control systems to ensure the safety and well-being of passengers and crew. Robert J. Maddox for development of quantitative models for predicting catalytic selectivity through fundamental understanding of reaction mechanism and kinetics. Sandra H. Magnus for national accomplishments in the U.S. Civil Space Program and in Department of Defense Engineering and Technology Integration. Ravindranath V. Mahajan for contributions to advanced microelectronics packaging architectures and their thermal management. Michelle V. Manuel for contributions to research, implementation, and teaching of computational materials design of biomimetic self-healing metals and high-performance lightweight alloys. John C. Morrow for developing and applying data-driven models and machine learning that enable high-strength, damage-resistant glasses. John D. McDonald for leadership in smart grid development and for advancing the professional growth of power system engineers. D. Nathan Meehan for technical and business innovation in the application of horizontal well technology for oil and gas production. Sanjay Mehrotra for contributions to non-volatile memory design and architecture enabling multi-level cell NAND flash products. Roland J. Manassa for contributions to robotics and automation in aerospace, automotive, and e-commerce. Paul Mensa for leadership in accelerating process development of biotherapeutics, including the key components for the first approved COVID-19 vaccine. Daniel N. Miller for theoretical contributions and practical innovations in flow control that improve the performance of aircraft propulsion systems. Stephen G. Monosmith for development of physically based understanding of freshwater and coastal fluid environments for ecosystem health and sustainable management. Michael A. Musselham for making transcatheter delivery of artificial heart valves possible and saving over 650,000 critically ill patients to date. Roger M. Myers for technical leadership in the development of advanced electrical and chemical space propulsion systems. Farzad Naeem for advancing performance-based seismic design of tall buildings and other structures with instrumentation, isolation, and energy dissipation devices. Klawa Narstedt for contributions to managing quality of service in distributed multimedia systems and networks. Guy J.P. Nordenson for structural engineering and leadership in promoting structures as art and culture. Richard P. O'Neill for leadership and contributions to the liberalization and design of efficient natural gas and electric power markets. Danny Orr for contributions coupling soil physics, hydromechanics, and microbiology through novel measurements, theory, and models of key near-surface hydrologic processes. John W. Palmore for development of silicon carbide-based advanced electronic devices. Colin J. Parris for leadership and advancement of industrial operational technologies and innovation based on digital data analytics and the Internet of Things. Nelson Pedrero, for technical innovation and engineering leadership on programs of national importance in space exploration, strategic systems, and missile defense. Kenneth E. Peters, for development and application of geochemistry for basin analysis, hydrocarbon production, and biodegradation metrics. David A. Petty, for leadership in the development of high-temperature nuclear reactor fuels and for improving the safety of fission and fusion reactors. Mary Ann T. Phipps, for leadership in structural engineering and contributions to assessment, mitigation, and design of building components for seismic effects. Zoya Popovich, for developing high-efficiency microwave transmitters and active antenna arrays for wireless communication systems and for engineering education. Sarah A. Rayala, for innovations in engineering education, outcomes assessment, greater participation and retention of women in engineering, and an enhanced global community. Martin I. Ryman, for contributions to network theory and applications in large-scale stochastic systems. David K. Robinson, for process development innovations and regulatory filings that enable the worldwide availability of vaccines and novel antibodies. Nikolaos V. Sahinidis, for contributions to global optimization and the development of widely used software for optimization and machine learning. Guillermo R. Sapiro, for contributions to the theory and practice of imaging. Julia M. Shannon, for innovative and interdisciplinary applications of materials engineering in trimodal composites, coatings, additive manufacturing, and green engineering. Kate M. Scow, for elucidating the role of soil microbial communities in polluted ecosystems and the responses to agricultural management practices. Manoj R. Shah, for contributions to design, analysis, and electric machine performance enhancements. Pradeep Sharma for establishing the field of flexoelectricity, leading to the creation of novel materials and devices and insights into biophysical phenomena. Leslie L. Shoemaker for developing and applying innovative technology to complex, large-scale watershed management systems and sustainable water programs. Deepika K.P. Singh for manufacturing innovation and entrepreneurship of chemical mechanical planarization for wide bandgap semiconductors and super hard materials related products. Vijay P. Singh for contributions to wave modeling and development of entropy-based theories of hydrologic processes and hydrologic extremes. Daniel Sperling for leadership and outstanding entrepreneurial contributions in transportation energy, advancing alternative energy policies, and promoting government, industry, university collaborations. Leon Thompson for contribution to seismic anisotropy concepts that produce major advances in subsurface analysis. Masayoshi Tumizuka for leadership and control of mechanical systems through innovations applied globally in industry and education of coming generations of leaders. Franz Josef for contributions to nanoscale improvement of concrete and other materials and structures important for sustainable development of infrastructure and energy resources. Manuela Veloso for contributions to artificial intelligence and its applications in robotics and the financial services industry. Solveig M. Ward for contributions to electric power system protective relaying and new data communication technologies. Michael M. Watkins for leadership in the development of space geodesy and leading robotic missions for exploration of the Earth and planetary bodies. David West for solutions to problems with technological, commercial, and societal impacts while advancing chemical sciences by applying reaction engineering fundamentals. Telly Whitney for contributions to structural silicon design and for increasing the participation of women in computing careers. Karen E. Wilcox, for contributions to computational engineering methods for the design and optimal control of high-dimensional systems with uncertainties. Charles E. Wyman, for advances in transforming lignocellulosic feedstocks to low carbon footprint fuels and chemicals. Yusha Yen, for creativity, innovation, and entrepreneurship in separation membranes and electrochemical reaction engineering, catalysis, and materials. Jim Yurko, for innovation, leadership, and the accelerated development of materials applied to consumer electronic products. So, now on to the induction of the class of 2022 international members. If we could ask International Secretary Jim Tien to come to the stage and allow Carol Hall time to return to her seat. Joseph Altentash, for contributions to metal cutting mechanics and machine tool systems research and industry applications. Juan Andres, for technical leadership in the scale-up and manufacturing of important pharmaceutical products, including the COVID mRNA 1273 vaccine. Nigel P. Brandon, for contributions to the science and engineering of solid oxide fuel cells and their technological development and commercialization. Jerome Feist, for contributions to the development of mid-infrared and terahertz quantum cascade lasers. Ravindra D. Kulkarni, for innovation-centric business and technology development and leadership across disciplines. Wokwon Kwan, for contributions to model predictive and robust controls and their commercialization. Bin Liu, for bringing organic electronic materials into aqueous media, opening new directions in biomedicine, environmental monitoring, sensors, and electronic devices. Heike Reel, for global leadership and technical innovations in the semiconductor industry, covering OLED, fundamental device processes, materials, and nanowire devices. Kei Chin Chai, for international leadership and contributions to earthquake engineering research and the design of steel structures. Rodney S. Tucker, for contributions to semiconductor lasers, high-speed optoelectronics, and energy-efficient optical networking. Ganapati D. Yadav, for research, innovation, and education in green chemistry, catalysis, nanotechnology, and chemical engineering leading to clean and green technologies. Oz Yilmaz, for leadership in developing innovative methods for processing seismic reflection data and educating a generation of geophysicists. Hongjian Zhang, for technical contributions and leadership in the area of multimedia computing. Okay. Congratulations to the NAE class of 2022. Okay, now some logistical instructions. We would like the class of 2022 U.S. and international members to leave the room first. We'll be taking a class photo. If the rain has stopped, it could be in the outside steps. If not, we have a stage set up down in the so-called East Room. So allow the new members, as well as anybody celebrating their anniversary, to depart first to have a photograph taken. After they've all left the room, then the rest of us can go out and have a break and before we resume the program later this afternoon. You should go out there too. I think they're taking anniversary pictures somewhere. Yeah. Yeah, out that way. Look at